How's it going, everyone? I'm Nick, and you're listening to the Fresh Perspective Podcast. Did you get a chance to listen to our last episode about our journey back through 4 billion years of Earth's history? If not, please pause this episode and go check it out. I'll be sure to leave a link below. This episode is the second part in a series where we will be looking back through the past, a few billion years at a time. If you invented a time machine and began to travel backwards, what would you see? How far back could you go? In this episode, we will try to wrap our minds around some planetary science, astrophysics, and cosmology as we rewind time at 1 billion years per minute with the help of a little imagination. This program is brought to you by the members of the Free Thought Initiative. We help those in need of an inclusive, supportive, and free-thinking community by hosting public discussions on moral philosophy, healthy living, and science to improve the cohesion, health, and scientific literacy of our society. Everyone is welcome, regardless of personal religious belief, political leanings, etc., to participate in person in these open and civil discussions. To find a free thought forum meeting near you, to start your own local group, or to become a member and support this program through monthly donations, please visit freethoughtforum.org. Now that was a good lunch. I noticed you were looking out the window. Are you hoping to see something swimming out there? It's unlikely. We have already traveled over 4 billion years into the past. As far as we know, our planet is now completely barren. True, there are organic molecules all over the Earth, but they're not quite yet alive. Did you hear that? It could be an earthquake or a volcano. Most likely, the Earth has been hit. You see, this far back in time, the space between the planets of the solar system wasn't quite as empty as it is in our time. There is an awful lot of space junk up there being collected by gravity into anything big close by, like us. Our time machine is about to surface, and then we can continue our trip back to the beginning of time. To tell you the truth, we aren't even halfway there. Are you ready? Alright, I'll reset our speed to travel at about 1 billion years per minute, or at about 16 million years per second. Our computer will also let us know when we reach each billion-year milestone. Go ahead and pull that lever back. Our vehicle glows and twists space-time, hurtling us back into the past. We are in the Hadean Eon, looking down as much of our oceans boil and rumble into clouds of steam. The clouds are reabsorbed into balls of rocky ice, comets, which fly off in all directions, leaving massive craters in the hellish landscape of our infant planet. We pass through the late heavy bombardment, in which the Earth and Moon is pelted non-stop by asteroids, meteorites, and all kinds of space debris. The Moon flies past us dangerously close to the surface of the Earth, spiraling in until it dissolves into countless rocks and globs of Earth. For a few seconds, our lava planet has no moon, but has at least a partial set of rings. At 30 seconds into our journey, the planet shakes and is almost broken in half. Its rings and vaporized rock atmosphere reform into its surface and a protoplanet about the size of Mars, which struck the Earth. This protoplanet, named Theia, flies back into space, reassuming its doomed spiral toward us. More evaporated water is pulled back into our infant world, a red-hot ember of molten rock and radioactive elements. From here, you can almost see the light, rocky elements of the crust falling and the heavy metal elements rising, mixing the world up into a liquefied mess as rocks from space continue to bombard it. We pull back to keep our distance in just enough time to see our world spin faster and faster, flinging its rock, metal, and water out into space. In no time at all, it's gone. The Earth is nothing but a massive cloud of light elements, a dust pile around a new star. I was so focused on our planet that I missed the formation of Mercury, Venus, Mars, or Jupiter. All the planets, moons, and objects in our solar system have now dissolved into a scattered and dusty gas cloud. Once we pass 40 seconds back, the light goes out. 99% of the mass of our solar system is no longer condensed by gravity enough for nuclear fusion. The matter around us is no longer compact enough to form a star. In a few more seconds, we drift in the darkness of space, unable to tell that we were once in a system of majestic planets. If you look down there, you can see the constellation Libra. Below that, you can see the stars of the Southern Cross. Between those two is the Centaurus constellation. Do you see the brightest star? That is where you can find the Alpha Centauri system of 3 stars and a planet. Proxima Centauri is the closest star to us, but at about 50 seconds, we see it fly further away, and then shrink back into its own stellar nursery of gas clouds. Surrounded mostly by invisible hydrogen and helium in a molecular cloud, we see the stellar siblings of our Sun grow closer to us, only to also be snuffed out in the rewinding of time.
5 billion years ago.
At this speed, you can see some of the constellations slowly contort and become unrecognizable. Some stars in the other constellations go out, while others remain unchanged. The expansion of the universe is stretching the space between the galaxies, but we are seeing this in reverse. In fact, distant stars and galaxies seem to be rushing closer. Don't worry, we have plenty of time before they collide with us. They appear to be moving quickly now because we are in the dark energy-dominated era. Pretty soon, the mysterious dark energy that accelerated this expansion will, for some reason, have a weaker effect.
6 billion years ago.
From here, you can see the bright center of our galaxy. There is an ancient black hole there, and it usually takes our Sun about 225 million years to circle it. At our speed of 1 billion years per minute, we will rotate around the center of the galaxy about every 14 seconds. Our Milky Way has about 100 billion stars, and there are about 125 billion galaxies in the universe, but that number is slowly dropping as we fly through history. As far as we know, we are the only living things that can see this view out the window. What is so special about the stars and galaxies out there? To be fair, it still looks a lot like something you'd see from the Hubble telescope. Well, we've made it halfway. We have traveled through half of the age of the universe. In other words, we are halfway to the Big Bang.
7 billion years ago.
After 7 minutes of travel, our Milky Way is starting to change its size and shape. Many of its stars, including our Sun, have gone out, but long-dead stars have reignited. Smaller galaxies slowly pull away from it, and the Milky Way has begun to shrink. Some parts of our home galaxy house some of the oldest stars in the universe, so we shouldn't expect it to vanish anytime soon.
8 billion years ago.
Superclusters begin to break apart into clusters, clusters into groups, and groups into lone galaxies. Neighboring galaxies in our own local group are spinning and dissolving into smaller clusters of stars. For the next 6 minutes, you are going to see a lot of that. The universe is expanding in reverse for us, so as it slowly closes in, it is getting easier to spot other galaxies shrinking, splitting apart, and growing dimmer, as fewer stars set them apart from the inky black cosmos.
9 billion years ago.
The universe is only 4.8 billion years old now, and many of the elemental clouds that would give birth to future stars are collapsing into supernovae, blinding explosions that flash for the briefest instant, only to swell back into supermassive stars where most of the heavy elements of the cosmos are cooked.
10 billion years ago.
The edges of the universe have again begun to speed up toward us. The universe is only 3.8 billion years old now, and it's getting warmer. Gravity hasn't had much time to clump all the galaxies together, so the stars we see are far more spread out compared to what we are used to seeing. To us, our own Milky Way has become unrecognizable, but I'm sure that there are some experts that could point out some notable features even this far back.
11 billion years ago.
Wait, have you been touching any of the controls of the time machine? I haven't. It seems like we're getting faster. Does time itself warp more dramatically the closer we get to the Big Bang? I don't know, but it is a fascinating thing to consider.
12 billion years ago.
It is really dark out there. There are a few stars near us, and there must be countless other stars, but most of them are just too far away for us to see. It was nice when there were bright galaxies, but I can't even see them anymore. There are plenty of black holes out there. The truth is, we could fall into one of the smaller ones at any moment, and we wouldn't even see it coming. Look, even the oldest stars, quasars, and dwarf galaxies are going out. In a few seconds, we won't see a single thing. I don't think I've ever seen anything so dark.
13 billion years ago.
Our sensors are picking up on a great deal of ultraviolet light. The space around us is quickly heating up into a kind of plasma. Blasts of light come from blinding hypernovae, the death of the very first stars. They were supermassive hydrogen giants. Now that they have reformed, we have crossed into a universe ruled by energy, not matter. The hydrogen giants weren't formed by gravity collecting hydrogen gas alone. No, most of the stuff out our window is dark matter, as has always been the case, accelerating the collection of molecules together. At 13 minutes and 50 seconds into our voyage, even the first black holes are evaporating back into their stellar forms. Matter is spread fairly evenly across the cosmos. We are plunged into darkness yet again. This is fitting because we have crossed into the cosmic dark age. At our current speed, it isn't going to stay dark for very long. White light floods our windows, like a searchlight right into our eyes. No, that isn't some explosion or star. That is a wave of photons released from the recombination and decoupling stage of our universe. The first neutral atoms had just formed, allowing tremendous amounts of energy to fly free in the now transparent cosmos. We can even see this energy back in our own time as the cosmic microwave background radiation. Just as suddenly as the light arrived, it vanishes. The universe is now dark and opaque, a dense, foggy soup of plasma, like in the inside of a star.
Alert! Alert!
This is the end of the line for us. I know we wanted to go further, but I have to insist.
Turn back now.
The universe is only 47,000 years old, but this is as far as we can go. It is getting so hot outside our time machine that atoms are no longer able to hold on to their electrons. In other words, our time machine will soon dissolve into a plasma itself. If we travel much further, we will be ripped apart by antimatter and crushed by the pressure of the universe closing in around us.
Hull integrity decreasing.
There is no time for debate. Our craft can't take this heat. Push that button to reverse our course. Hurry. Now that was an adventure. Now that we're safe back home, I really can't wait to get my feet back on the ground. I hope you aren't too disappointed that we couldn't see the Big Bang. I suppose that no time machine, probe, robot, or spacecraft can really go much further back in time than we did. However, if you would like to perform a thought experiment to see if we can go back to the Big Bang, and even before it, I do have an episode of this podcast called What Happened Before the Big Bang. Why don't you give it a listen? I bet you'd get a kick out of it. That is all I have for you today, but the conversation continues across social media and in the comment sections below. Do you agree with today's message? Am I mistaken about some detail? How can I better elaborate on this topic in the future? Feel free to share your perspective.